Do not write anything, just watch for a moment. This will be, this is power, no, it's just multiplied by 5, sorry. Let me just make sure it's, okay, so would you allow me to, let's say, simplify 2 of these with 2 of these? Okay, what did we say last time? That we only simplify? Never. I am not allowed to simplify terms. I'm only allowed to simplify factors. So let's repeat. Is this a factor at the top that I could simplify with a factor from the denominator? The answer is no. This is part of a term. It cannot be a factor. So I cannot do that. So this would be a terrible mistake to try to simplify 2 from here with 2 from here, because this is part of a term and I cannot simplify. So please make a note of that. That's why I said please create that notebook in which you put all the important information. I'm not allowed to simplify this. This is a factor at the bottom, but this is not a factor at the top. It's part of a term. This is a term. It's a piece of a term. Okay, so now let's look at the top, and I'm sure you notice that the numerator is not completely simplified. What will you do? How will you rewrite the first term? 8x. Excellent. 8 times 2x minus 3 cubed and 5x minus 1 squared. Awesome. And then? Very good. 10 times 2x minus 3 to the 4th and 5x minus 1. This must be the first step. We are cleaning it up. One more time, how many terms we have at the top? 2. Good. So let's try to find common factors. Do not look at the denominator just yet. So please tell me about the top. I see an 8 and I see a 10. Do these two have a common factor? 2. Perfect. Now I see 2x minus 3 cubed and 2x minus 3 to the 4th. Are they common? Is this a common factor? Good. Which power? Very good. Then I continue. I see 5x minus 1 squared in the first one and 5x minus 1 in the second one. Is that common? Yes. Perfect. So 5x minus 1, which power? First. Very good. Now don't forget about the brackets. At this point, you're ready to open brackets. Okay. So step by step, slowly. I took 2 out of 8. What is left inside such that 2 times this number is 8? Perfect. From 2x minus 3 cubed, I took all of them out. Is there any remainder? No. From 2 of those, I took 1 out. One of them in parentheses, 5x minus 1. And now at this stage, finally, I reached the negative sign that I have to copy. Then I continue. From the second one, from 10, I took out a 2. What is left? So then this times this is 10. 5. Perfect. Then from 2x minus 3 to the 4th initially, I took out 3 of those. Is there anything left inside? 1. Very good. With parentheses because it needs to be multiplied. And then 5x minus 1 is out. Is there anything left from the 5x minus 1 to the first power and 5x minus 1 to the first power? Good. Excellent. Now I can do this. Why? Because all of a sudden, 5x minus 1 became a factor. So I pulled out, or I simplified the factor of 5x minus 1 from the top with 1 from those 4 from the denominator, which I could not do before. Okay, so then I write 2x minus 3, and now we'll simplify in parentheses over 5x minus 1 to the 3rd. Can anyone give us the first step in parentheses, or brackets, I'm sorry, in brackets? that now I changed to parentheses.
So 4 times 5x is 20x
Very good.
minus 4
Very good.
minus 10x
Very good.
minus 15 or
Plus.
15.
Perfect. So the final step, I have to simplify this and I'm done. So, oh, I'm sorry. Please copy the 3. I forgot to copy the power. Sorry about that. So 2x minus 3 to the third, and now in parentheses, and 5x minus 1 to the third. So once you redo these two problems, the other 5 would be a piece of cake. So I have a 20x minus 10x, which is 10x, and I have a negative 4 plus 15, which is positive 11. And this is the simplified form. Please, for Wednesday, redo these problems more than once, and then do the other 5. You should have no difficulties, but if you do, we'll do them in class. Any questions? Any questions?
Wait, I'm sorry.
Go ahead.
Okay, I get it now. So 20x. It's so overwhelming to look at.
Yes.
It's like I feel like
But
my
once-
eyes just need to figure out where I'm looking.
I completely agree. But once you break it down into small pieces and you see one term and then you see another term, yes, it takes a while to get used to it. Oh, absolutely.
Or otherwise, like it's even 20x minus 4 minus 10x plus 15. I'm like, oh, okay, that's easy. But I'm like looking at it here and I'm like,
Right.
wait a minute, I'm like, where the hell is that?
I have to say that I'm trying to keep my mind active. So I'm learning whatever I can, a little bit every day. It takes me, but I have an old brain. You have a fresh brain, right? Young brain and ready to learn. For me, it's way more difficult because I have to write it, I have to pronounce it, I have to write it, I have to pronounce it, I have to do this, I have to rewrite it, I have to do the exercises. It takes forever. It takes forever. So exercise your brain from early age and you'll feel great. Okay, so we're done with factoring. And now I would like to go back to section 1.5, quadratic equations, because we have to look at 3 other methods of solving quadratic equations. We are done with only factoring. So let me write this again for you. So please do the other 5 so you can get used to them. Check the answer. The answers are at the bottom. And come back and I'll help you with if you have any questions. So let me refresh your memory. We are looking at 1.5, quadratic equations. And there are 4 methods here. And we only looked at 1. We refreshed our memory. In the past, when I taught this class, not this class, the previous class, it took me a month to do factoring with that class because it was an entire chapter 6. And it took us a month to learn factoring. Here, we did it in what? Less than an hour and a half, right? Because it's something that I wanted to review from scratch, but we should have known this by now. But it's okay. As long as you're reviewing it and redoing it now between now and Wednesday, and every now and then you look at your notebook, you should be fine. Okay? So we looked at factoring. The next step is taking square roots. The next one is completing the square. And the last one is quadratic formula. Okay, so now the obvious question is this. 4 methods, really? For one little thing, for one quadratic equation, 4 methods? Yes. Because different situations require different methods. For example, which of these 4 are always applicable? These 3, because factoring is not always applicable. Not all polynomials are factorable. But all these 3 will work. For example, number 3, when will I ever solve a quadratic equation with this? The correct answer is never. So this is a method that cannot solve a quadratic equation. So then why? So the answer is at the end of chapter 2, you will understand why we study this method. But when it comes to quadratic equations, I will say I will never, unless you force me to, I will use it. But if you don't force me to, I will never use this one, ever, on solving quadratic equations. So then what will I do? I will use this if the setup is appropriate, and I'll show you in a minute. I will use this if it takes less than 30 seconds. If it takes more than 30 seconds, forget it. I will use this. So this one, in specific situations only. This one, if it takes 30 seconds or less. This one, always. This one, never. We need it, though, for something else in chapter 2. Okay, so I only showed you how to factor polynomials, but I didn't show you any solving a quadratic equation by factors. So I'm going to choose a problem because we are going to review that down the road. So let's say, yes. So number 4 on page 167, in which we have x squared equals negative 11x minus 10. So what type of equation is it? Well, the answer is yes, it's a yes. Okay, very good. So let's differentiate between two things. Type of equation, I have to answer in this case quadratic, which means second degree, which means two solutions. Second question that is different than this is the type of polynomial, which is trinomial. It's confusing, so that's why we need to talk about these things. So when I'm given an equation, I always ask myself, what type is it? And I know 3 types by now. I know linear, I know rational, and this is the third one, quadratic. Now, when I'm asking what type of polynomial that is, you can say quadratic polynomial or a trinomial. Is this clear so far? Okay, so if I'm asked to solve something like this by factoring, I have to have 0 on one side. Meaning I will move these two terms. They are negative on the right, they will be positive on the left. So this is x squared plus 11x plus 10 equals 0. So if no one tells me what to do, and factoring takes more than 30 seconds, I'll forget it. Use anything else. I don't want to waste my time. But if I'm forced to factor, then I'll have to factor. So now it is a trinomial. It's in descending order. Greatest common factor, no. Negative leading coefficient, no. Special product, no. But luckily, 1 is the leading coefficient. So what do I do? What is the factor form of this? Product is 10, sum is 11. So there are two options, x equals and x equals. Remember, this is the 0 product principle. A times B equals 0 means either A is 0 or B is 0. So when I set x plus 10 equal to 0, I move 10 to the other side. It was positive on this side, it will be negative on the other. We used this before in restrictions for rational equations. And what is the other option? That's it. And you're done. So this is the method of factoring to solve quadratic equations, or solving quadratic equations by factoring. That's it.
I have a question.
Yes.
So I know how to do it and everything, but on the math lab or whatever,
Yes.
how does it want you to put it in? Because when I was doing it, it kept saying it was wrong.
You have to show me a problem so we can look at it and see what it
Okay,
is.
I
But
took a
it's
picture.
probably asking you to write negative 10 comma negative 1.
Okay.
I'm assuming, but I have to look at the problem. Okay. So now let's talk about taking square roots, method number 2. When do I use this method? Only when I have something like this. 1 in front, and something with x in it. I don't know, 2x minus 3. What kind of equation is this? I should have written this from the beginning here. Second degree, 2 solutions. So I don't forget. Second degree, 2 solutions. Okay, what is this? What type of equation is this? Second degree, 2 solutions. Quadratic, we're still talking about quadratic, so it's quadratic. When you expand 2x minus 3 squared, remember the formula from the first day of classes, the first term squared minus 2 times the first times the second plus the second term squared. So it's quadratic. Let's put a number here. Just give me any number you want. Okay. If we use 4, then it's easier for a... We don't have to. We're going to look at more examples. So if the problem, the quadratic equation is given like something with x squared, 1 in front, and a number, then we can take the square root from both sides. I will use taking square roots only in this situation. 1, the leading coefficient outside, something with x inside, the squared, and a number on the other side. It can be positive, 0, or negative. So now, since I have to write 2 solutions, what do I have to remember? You may remember this or not. Let's say we don't remember. Okay, so if I look at the following equation, I'll come back to the original one. So I just want to explain something before we continue there. So if I have x squared equals 4, and I take the square roots from both sides, the left-hand side is correct. It should be the absolute value of x, though. Okay, and the right-hand side is?
Plus or minus.
Exactly. But not to be understood that the square root of 4 is plus or minus 2, because it's not. So the correct answer from here is the absolute value of x is 2. What are the numbers whose distance from 0 is 2? And the answer is 2 different numbers. And that's why we write x equals 2 and x equals negative 2. What is the point I'm making with this explanation? Is that I want you to understand that the plus or minus do not come from the square root of 4. The plus or minus come from this side, from the absolute value. So please do not ever think that since you are taking square root from 4, from left and right, and you write plus or minus, do not ever believe that the square root of 4 is negative or positive 2. Negative the square root of 4 is negative 2, but positive the square root of 4 is only 2. One more time, plus or minus do not come from this side, but from this side. But we omit this step. So when I continue here, I will write 2x minus 3 equals plus or minus 2. But the plus or minus come from this side, where I should be writing the absolute value of 2x minus 3. This is a linear equation. We know how to solve a linear. So how do I continue here?
Divide both sides by 2.
I have to move 3 first.
Oh.
Yeah.
I have to move 3 to the other side. So 2x equals 3 plus or minus 2. And then I have x equals 3 plus or minus 2 divided by 2. Can I simplify this 2 with this 2? This 2 with this 2.
No, because the first term.
Because they are terms. Awesome. But I have to separate them, though. How much is 3 plus 2?
5.
So this is 5 halves. How much is 3 minus 2? So this is 1 half. So this is the method of taking square roots. So now let's choose from your book. Let's say 22. We are on page 167. X minus 3 everything squared equals 36. A simple problem. I hope you're going to find it easy. So what type of equation is it? Well, still quadratic. We're still working on quadratic. So how many solutions do we have to get? 2. So is it already set up for taking square roots? Yes, it is already set up for taking square roots. So I get x minus 3. So don't forget, second degree, 2 solutions. You can write it on your paper all the time so you don't forget, because if you don't write it and you just find one solution, that will not be correct. So the answer on the other side is, that's why we wrote second degree 2 solutions. Good, good. However, the square root of 36, you understand, is not plus or minus 6. The plus or minus come from this side.
I have a question.
Correct.
Can
Yes.
we separate it like that? Like, can we do x minus 3 equals positive 6, x minus 3 equals negative 6?
Yes, but I don't recommend it because the easiest method, but that's fine. The easiest method is x equals 3 plus or minus 6, and now you separate it. Because otherwise you have to solve 2 different equations instead of solving 1. But yes, you can. But I recommend this. So 3 plus 6 is, and 3 minus 6 is, that's it. Are we okay with taking square roots, or we need another? Is this okay? So when do I use it? In a specific situation. When I have 1 in front of the parentheses, some expression with x squared equals a number. Do you think we need another, or we can move on to the third method? Are we okay with taking square roots?
Yeah.
Yes? Okay. So let's take a look at method 3. Completing the square. I'm going to choose a problem, illustrate, and explain step by step. 48 on 167. And here's the equation. X squared plus xxx equals negative 8. We are forced to use complete the square now. If we like it or not, we have to use it. Okay, so what does this say? What do I want? I want to use some steps that I will explain in a minute to make this look like this. Is this familiar? So that I can apply what? Because the method itself is not going to solve the equation. So I'm changing this into this kind of equation because I need to apply taking square root. So that's why I'm saying complete the square is not a method that will solve an equation. It's useful for something else. Can you complete the square and then apply this? Yes. But this is like doing this instead of doing this, right? But it's a very important method. That's why we talk about it now. Okay. Well, what are the steps? There are 4 steps between this and this. 4 steps. So complete the square is a 4-step procedure. Step number 1. Identify the middle coefficient. But the polynomial has to be what? So I can identify it. It must be in the descending order. If it's not in descending order, how will I know which one is the middle coefficient? Is this polynomial in descending order? Perfect. And the middle coefficient is? Excellent. Step 2. Divide 6 by 2. What do I get? Very good. Step 3. Square 3. What do I get? Final step. Add 9 to both sides. So let's recoup for a moment. So The method of complete the square has 4 steps. Step 1, I have to make sure that the polynomial is in descending order, and I have to identify the middle coefficient, not the leading coefficient and not the free term, the middle one. Good. In this case, it's 6. Then I divide it by 2. I get 3. Then I square 3, and I get 9. And this is what I have to add to both sides. So now the equation looks like this. X squared plus 6x plus 9 equals 9 minus 8. Notice that if I do not add 9 to both sides, I change the equation. If I add 9 to both sides, I will not change the equation or the solutions. I may change outlook, but not the solutions. Adding 9 to both sides is allowed. Okay, so now I know what this is because I just reviewed factoring. It's a trinomial, it's in descending order, no negative leading coefficient, no greatest common factor. And I hope for a special product. Of course it's a special product because that's what I am looking for. That's what I want. I made this a special product. So what is this? We had it with A few minutes ago.
X plus 3.
Very good. And the right-hand side is? Exactly. After all this effort, I cannot even solve. I have to use method 2 now. So I take the square root, and I get x plus 3 equals, and I know what type of equation this is, so I will not forget a crucial piece. Exactly. So then x equals negative 3 plus or minus 1, and I have to separate them. Why? Because they can be simplified. So negative 3 plus 1. And negative 3 minus 1. And that's the method of completing the square. And of course, we need more practice, I know. Ready? We want one with fractions? Yeah. Good. I didn't expect a yes on that. Thank you. That was good. Okay, 56. X squared plus 7x minus 8 equals 0. We're asked to use completing the square. You can, from the very beginning, if you want to, you can move the free term to the other side. If you think that it's in the way, do it from the very beginning. I like to do it in 2 steps, but I think it's better if we do that first. Okay, so is this polynomial in descending order? Perfect. So now I have to go through a 4-step procedure. Question number 1, what is the middle coefficient?
7.
Good. I divide it by 2, and I get 7 halves. And now I have to square 7 halves. Remember how we square a fraction. We square the top, and we square the bottom. This is what I need to add to both sides. So this is x squared plus 7x plus 49 over 4 equals 8 plus 49 over 4. Again, make sure you're adding it to both sides. And now the left-hand side must be a perfect square. We made it. It must be a perfect square, and then the right-hand side, we will add those 2 fractions. So it's not a big deal. It's not a huge, difficult method, but it requires these 4 steps. It requires paying attention and making sure that you're on the right track. So obviously it's x squared, and obviously plus, and obviously what I squared to get that.
So x plus 7.
Exactly. How do I know? Let's expand it like on the first day of classes. The first term squared is this, plus 2 times the first times the second would be 7x plus the second term squared. The least common denominator is 4. I need to multiply the top of 8 because 8 is 8 over 1. So then I have 32 plus 49. So then the left-hand side, x plus 7/2 squared equals the right-hand side, which is, okay. After all this effort, the point I'm making is, complete the square alone is not going to do the job. So now I have no choice but go back to the previous method, method number 2, and take the square root from both sides. The left-hand side is x plus 7/2. It should be the absolute value. Instead, remember this is a quadratic equation, and there is an important piece of the puzzle, which I cannot forget, which is 9/2. Excellent. Thank you. So x equals negative 7/2 plus or minus 9/2. Yes, I have to separate them because I can simplify them. Negative 7 plus 9, negative 7 over 2 plus 9 over 2. Negative 7 plus 9 is 2. 2 over 2 is 1. Negative 7 minus 9 is 16 divided by 2, which is, that's it.
How did that,
Yes,
how did it turn negative? How does that work?
negative 7 minus 9 is the second one, which is negative 16 divided by 2, negative 8. So minus with minus, and then minus with plus. Negative 7 plus
No, I'm
9,
saying, how did it go negative? Where you wrote it red.
this one,
Yeah.
because when we take the square root from both sides, we have to obtain two solutions. So that's why we have to write plus or minus.
I need to say where did you get the negative 7 over 2?
Oh,
Yeah,
I
you
moved
have
it.
to move
I moved it. So when I move a term from one side to the other, I have to change
Oh,
its
you
sign.
moved it. Okay.
Yes. Yes. Is it okay?
Yeah, but why'd you move it?
Because I'm solving for x. And that's how we solve linear equations. We have to separate x from everything else. Everything else has to move to the other side.
Would you just go more of these?
Yes, of course. Is this clear?
Yeah.
Perfect. Yes. Would you like to choose? Or you want me to choose?
You choose.
I choose. So let's say, yes, 53. X squared plus 4x plus 1 equals 0. Would you like to move that 1 from the very beginning to the other side or not?
Yes.
Okay, that's fine. So then x squared plus 4x equals negative 1. 4-step procedure.
Do we do this for all of like do we move the number? for all
That
of
number has nothing to do with the perfect square that we are trying to build.
them? Okay.
Yes, very good question. So you either move it from the beginning or after you add to both sides. But I think it's better not to get confused, and maybe it's better to move it from the very beginning. Yes. Perfect. So the middle coefficient, first of all, is this in descending order?
Yes.
Middle coefficient divided by 2. 2 squared. What do I have to add to both sides? Very good. X squared plus 4x plus 4 equals 4 minus 1. Make sure that you add it to both sides. Otherwise, it's going to be an error. So now I know the left-hand side. I factored this several times already. I know this is a perfect square. I made it to be a perfect square, which
So x plus 2 squared.
exactly. So now I get stuck if I don't remember what to do next. Yes, I have to take the square root from both sides. So I take the square root from the left, take the square from the right, x plus 2. I have to put something very important because I'm expecting two solutions, plus or minus the square root of 3. So then x equals negative 2 plus or minus the square root of 3. There is no need to separate. However, my math lab may ask you to put a comma between the two because they may not have plus or minus.
We do a plus or minus.
Okay, so if they ask you to put a comma, then you separate them. But in this case, I don't need you to separate them. Any questions? Okay, last method, the quadratic formula. Now you understand that factoring doesn't always work. You understand that taking square roots works always, because I can always complete the square and then take the square roots. Complete the square works always, and the quadratic formula, which is number 4, will always work. Just factoring may or may not be applicable. So quadratic formula. Should I shut the door? Does it bother you? Yes? So in order to use the quadratic formula, the quadratic equation must be set, or the polynomial must be set equal to 0. If the quadratic equation does not look like this, set equal to 0 in other words.
Is that a minus? See,
No, plus. I wrote the equal symbol by mistake. So A, B, and C are those coefficients that we have to identify. And of course, we identify them with the sign in front. So then the quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. What does this mean? First of all, I want you to make sure that you will never, and promise, you will never write a negative number here. No matter what b is, when I square any number, the answer must be positive. Any real number, the answer must be positive. Okay, so please remember that. So let's look at a couple of examples. I know I only have 3 minutes left. So let's take a look at, let's say, x squared plus 8x plus 12 equals 0. And this is problem 66 on 167. And then I wanted to show you a word problem, and I don't think we can do that in 3 minutes. Okay, so first I identify A to be 1, B to be 8, and C to be 12. All I have to do is now carefully replace A, B, and C in the quadratic formula by these numbers. Negative b will be negative 8 plus or minus the square root of, which is 64, minus 4 times 1, I don't need to write times 1, times 12, over 2 times 1, which is 2. I want to show you how to put this in the graphing calculator. Okay, so here it is. So don't forget to put left parenthesis for the top. So I want to emphasize this before we do it. So in the graphing calculator, you have to have parentheses here. And in most calculators, you have to have parentheses here under the square root. Do not forget that. You'll get something else if you don't put the appropriate parentheses. So the left parenthesis at the top. Then I have minus 8. When I start with a negative, I have to put this symbol, the negative symbol, not the operational symbol, plus, and then the square root, in parentheses, 64, minus, I can multiply 4 times 12 is 48, close the parenthesis, come outside of the radical, and then divide by 2, and then press enter. You don't want to copy all this, so go to the second key and entry. And the calculator will copy what you had before. And the next step, you go and override the plus. Change the plus into a minus. And just press enter. You can plug it in again if you want to. But if you get lazy like I do sometimes, then you will go back and override the plus into a minus, operational minus, and press enter. So the two solutions are x equals negative 2 and x equals negative 6. Any questions?